In this video, we're going to talk about solving our systems of equations using substitution. So this is the first of our two algebraic methods for solving for the point that makes both equations true. Substitution method is used to solve systems of linear equations by substituting, replacing, an algebraic expression for one variable into one of the equations. That doesn't make a whole lot of sense, but as we look at the examples, hopefully it will make more sense. So let's write out our steps first. The first thing you're going to do is solve one of the equations for one of the variables. You're going to isolate the variables. In a lot of cases, this step's already going to be done for you. Then you're going to substitute that expression into the other equations and solve. What that's going to do is give you half of your answer. It's going to give you one of your values, either x or y, depending on which equation you're solving. Then you're going to take that answer, plug it into one of your equations. That's going to give you your other variable. And then, of course, we check. So we have two examples we're going to look at here. On example 1, we have y equals 3x plus 1 and 4x plus y equals 8. So you see right here how that y is by itself. So our step 1 is done for us. We don't need to solve for one of our variables because we already have that. We already have the y by itself. So our step 2, we go to the other equation, and what we're going to do is replace this y with what y is equal to. So y is equal to 3x plus 1. So we're going to remove this y. We're going to plug in 3x plus 1. So I'm going to have 4x plus, I'm going to take out the y. I'm going to plug in 3x plus 1. And then equals 8. I used parentheses here. I didn't need to in this case, so I can just ignore them. Sometimes I need them. You'll see an example 2. Once I've replaced the y with what the y is equal to, I now have an equation that just has x's. So I can solve this. Again, my parentheses aren't doing anything. There's nothing to distribute, so I can just ignore them. I'm distributing a 1 if you want. Then on the left side, I have some like terms, combining my like terms, and then subtracting 1. And finally dividing by 7. So at the end of step 2, I've got half my answer. In this case, I have my x coordinate. To find my y coordinate, I'm going to come right here to this first equation, and I'm going to substitute again. I'm going to replace the x with the 1. So my equation for y, I'm choosing the first one because it's already solved for y, so that's easy. I'm going to replace the x with what we now know x is equal to, which is 1. So I get a y coordinate of 4. So my answer here is the point 1, 4, or I could say x equals 1, y equals 4. If I want to check my work, I just need to plug it in to my original equations to see if it works. So I'm going to plug 4 in for y. I'm just going to do it right here. 4 in for y, 1 in for x. So I get 4 equals 3 times 1 plus 1, which is 3 plus 1. So that works. If I plug it in on the other one, 4 times 1 plus 4 equals 8. And hopefully you can see that that also works. So that blue is just me checking my answers. I'm going to erase it because it makes everything look messy. I usually do that part in my head. You might need to write it down if you need a little bit more practice than that. All right, let's look at example 2. So example 2 says solve the system of equations, negative 2x plus 3y equals 4, and x equals 2y minus 6. So see that x equals? My step 1 is done for me. My x is already isolated, so I don't need to do that. So what I'm going to do is I'm going to take what x is equal to, 2y minus 6, and I'm going to replace it in for the x in the other equation. So see, this is negative 2. I'm taking out the x. I'm replacing it with what x is equal to. I'm substituting, hence the name substitution. Everything else is staying the same. So that's my negative 2x, 2y minus 6, plus 3y equals 4. Now again, I have an equation with one variable. I can solve that. So I need to start by distributing. So negative 2 times 2y is negative 4y. Negative 2 times negative 6 is a positive 12. Plus 3y equals 4. And combining my like terms, a negative 4 and a positive 3, signs are different, so I subtract and keep the sign of the larger. Continuing to solve. I'm just going to keep going until I get the y by itself. Signs are different, so I subtract and keep the sign of the larger. Dividing by negative 1, I get y equals 8. So again, at this point, I have half of my answer. In this case, I've got the y. I know it's the y because it says y equals. To get x, I'm going to come back to this equation where I'm solved for x already. X equals negative 2y minus 6, and I'm going to plug negative 8 in for x. So I'm sorry, x equals 2y minus 6. So I am going to do x equals 2y minus 6. It's not negative 8, it's just 8. Sorry. And I'm going to plug 8 in for y. So I get 16 minus 6, which is 10. So my answer here is 10, 8, or x equals 10, y equals 8. Again, I can plug it in. I plug into the first one. I plug 10 in for x, I get negative 20 plus 3, 8 in for y, so negative 20 plus 3 times 8 is 24. That does in fact give me 4. And if I plug it in for the denominator, or for the second equation rather, I get 10 equals 2 times 8 is 16 minus 6. That's also true. So this right here is my answer.